we're going to continue with 9.5 and take a look at how we're going to graph tangent and cotangent functions. They're a lot different than sine, cosine, secant, cosecant because they're not waves. You don't graph any U-shapes. They're unique in their own way, and that's why they get their own little special section right here. As you can see right here, a lot of bullet points. These bullet points, they're only relevant when it comes to these parent functions. So you can take a look at them, and as we graph tangent and cotangent functions, you can reference back and forth with what they have down right here. The key things that we do need to know as we're graphing these is to try to figure out, well, what are the vertical asymptotes, and also what are the periods for these functions when it comes to tangent and cotangent. All right, so let's go ahead and take a look, scroll down right here, and what happens when we have some, vertical shifts or vertical stretch, horizontal stretch or shrink. Let's take a look at that first bullet point. It says the period of the graph of each function is pi over absolute value of b. So when it comes to finding tangent and cotangent periods, that's all you need to use. Okay, that simple equation. Now, with bullet points 2 and 3, this is where things get a little bit, well, you have to put a little more thought into it. The first, it's the second bullet point says the vertical asymptotes for y is equal to a times tangent b of x are multiple odd multiples of pi over 2 over absolute value b. You have to use that equation, and that equation right there only applies to tangent functions. But when we want to find the vertical asymptote to cotangent functions, these are actually multiples of pi over b. All right, so two different equations that you use to find the asymptotes. For tangent, don't forget, it's pi over 2 absolute value b, and it's odd multiples of that. So whatever you get right there, you're going to multiply it by 1, you multiply it by 3, multiply it by 5. Those are your odd multiples. When it comes to the vertical asymptote of cotangent, you're just going to draw lines at every multiple of pi over absolute value b. Let's put it all together. So we'll start off right here. Let's graph y is equal to tangent x. So we're going to figure out first, remember, find the period of the function, and it's pi over b. We'll write down right here, a is 1, b happens to be 1 as well. Remember, a is in front of tangent, nothing there, 1. B is in front of the x, nothing there, that means it's 1. So our period right here is going to be pi over absolute value of 1, which is pi. Then we're going to find the vertical asymptote of multiples of pi over 2 absolute value b. So right here, let's go ahead, we have ourselves pi over 2, absolute value of 1, and that's going to be equal to pi over 2. Now let's go to step 3, plot our intervals and draw our asymptotes. Now, as we've constantly been doing throughout graphing, we're going to go ahead and split things up into fourths. So let's go ahead, I'll draw 4 hash marks to the right and also 4 hash marks to the left. And these will represent our fourths. So we realize that our vertical asymptotes, remember, when it comes to tangent, it's going to be odd multiples of this for this problem, pi over 2. So what I'm going to go ahead and do right here is, remember, if we take pi over 2 times 0, that would be, that's not an odd multiple. So this right here is not going to work out. At 0, 0, this is not a vertical asymptote. So what I'm going to do is obviously pi over 2 times 1 is pi over 2. And I will go ahead and put that right over here. We skip the first hash mark. We go over to the next one. That's pi over 2. We could also multiply that by negative 1 and realize that at negative pi over 2, which will be over here on the left side, that is also going to be one of our vertical asymptotes. I'll go ahead and draw some vertical asymptotes right here. And there's a few other things we need to put into place. Now, in between these two asymptotes will be the middle, and obviously, and the middle point right here will be at 0, 0. That is the middle of this tangent function. So now, how do I figure out the rest of this? Well, we use we'll use the altitude, okay? And we know that a is equal to 1. So right here at 1, we'll label that 1. Here's negative 1. And tangent functions go left to down, up, from left to right, okay? So from the left side, it will work its way on up to the right side. So here's where I'm going to go ahead and put a point right here at the first hash mark, 1, and the next point will be down here at negative 1 at that first hash mark going in the negative direction. Now, where exactly are those? We call those halfway points if you look at the book. And the easiest way to find what the halfway points are is, let's go ahead, I'll write it right here, halfway point, and we could use pi over 4b, comma a. So a is 1. We realized that from the beginning. That's why I put using the altitude, putting 1 and 1 at those spots. Okay. Now, where exactly is that halfway point? It's going to be pi over 4b, which happens to be 1. So we have ourselves at pi over 4. That's one of our halfway points. So this right here happens to be pi over 4. Down to the left side, this is going to be negative pi over 4. So now that we have that down, I'll start right here from the left side down at the bottom and work my way on up. Going to that halfway mark, we'll have then it'll reach its way towards the middle, and then to the next halfway mark, and then go its merry way up near the asymptote. And remember, it doesn't cross. So right here, in between the asymptotes happen to be a period of pi. At the vertical asymptotes, at every pi over 2, you will notice, or every 4 parts, it's going to have an asymptote. All right, so if we were to draw another asymptote going to the right, I would take pi over 2 and then multiply that by 3. So then what I would do right here is draw 1, 2, 3, 4 hash marks. And then fourth one would be out here. And that would actually be 3 pi over 2. Taking pi over 2, multiplying it by 3. And on the other end, on the left side, it will be negative 3 pi over 2. So there is your tangent function. If you can't remember where exactly to start, think about this. You have to remember where the vertical asymptote is going to be. Now, for tangent, it's odd multiples of pi divided by 2 times absolute value b. So if you could figure out that, take your answer, multiply it by 1. That'll help you find your first 2 asymptotes. All right, let's go now. We could go ahead and try this problem right here, dealing with tangent 2x. So we're going to go ahead. A is 1, b is equal to 2, Next up, we want to find the period of the function. And so that will be right here. We take pi, divide that by absolute value of 2, and we got ourselves pi over 2. That is the period of the function. Step 2, let's find the vertical asymptote. And remember, it's odd multiples of pi over 2 absolute value b. And so we have right here pi divided by 2 times absolute value of 2, which is pi over 4. So we go to step 3, we're going to pull out our intervals. We have our draw our asymptotes. So remember, we got ourselves our fourths, 1, 2, 3, 4 to the right, and 4 to the left. And if we're only drawing one period, you actually don't need to have all 4. You just need 2 hash marks to the left, 2 hash marks to the right, unless there happens to be some horizontal translation. So what that puts us here is, remember, vertical asymptotes are odd multiples. So if I take pi over 4 and multiply that by 1, then that tells me my first vertical asymptote is pi over 4. So I'll skip the first quarter. We go right here, and then we got ourselves pi over 4. We'll go the other direction to the left. Remember, taking pi over 4 and multiplying it by -1 will get us negative pi over 4. What we need to figure out, remember, these two intervals right here, hash marks will represent the halfway point. So we use our, one of the things for our halfway point that'll help us is using the altitude. So right here we have ourselves 1 and -1 right there, because a is equal to 1. All right, so moving along, or not altitude, but amplitude, sorry. And then I do know that I'm going to have, all right, let's see, at pi over 4, let me go ahead and put, we'll draw our asymptotes. And I know that we have a point right here at 0, 0. We have something right here at something comma 1, and then at something comma -1. What exactly that is? Well, remember, we have our equation. To find the halfway mark, it's going to be pi over 4b comma a. And so we go ahead and figure out, we know what b is. It's going to be pi over 4 times 2 comma a, which is 1. So one of our halfway points is going to be pi over 8 comma 1. So what we can go ahead and put right here is pi over 8, and then down to the left side, this first hash mark will be negative pi over 8. Let's put everything together. We'll start from left, and the function will work its way on up to our halfway point, goes through it, goes through the middle, and then goes to the next halfway point, and then up. And that right there is your tangent is equal to 2x. The intervals changed. Remember, with b being 2, that leads us to having a horizontal shrink, and that's why the intervals happen to be a little bit smaller. Okay. Last up, let's take a look at cotangent. So in cotangent function, a lot of the things are the same. The big thing is number 2 right here, is finding the vertical asymptote. And remember, it is multiples of pi over absolute value of b, not odd. Okay, it's multiples of pi over b. So let's get started here. A is equal to 1, b is equal to 1. Hopefully we got that down. To find the period, we have ourselves pi over absolute value of 1, which is going to be pi. There's our period. Our vertical asymptote right here is going to be pi over absolute value of 1, and obviously that makes this pi as well. So the period and the vertical asymptote happen to be the same right here, and you'll see why in a bit. Let's go ahead. When we plot things out, we're going to go ahead and split up our intervals into fourths. And remember, if that's where our intervals are, is multiples of 1, right, or multiples of pi for this instance. What I'm going to go ahead is we add 0, 0. That'll be one of our asymptotes. Okay, so if I take pi times 0, that happens to be 0, and that'll be one of our asymptotes. Remember, when it came to tangent, it had to be odd multiples. So that's why we couldn't take our equation and multiply it by 0. But right here we can, and then we go out 1, 2, 3, 4. This will be our next asymptote. And this right here will be pi. Okay. So in this instance, we'll just go ahead and draw this out right here. We have this point in the middle, in between the two asymptotes. So that'll be one of our points. We'll use our amplitude right here, which happens to be 1. And I'll go ahead and put 1 and -1 down right here. So I do know that I'm going to have a point. Now, with cotangent, it actually goes down from left to right. So I know that's why this time I'm putting a point up above right here, the midpoint, and then down below to the right of it, or left, right side of it. Where exactly is this middle? Well, we could take pi, multiply it by 1/4, 1/2, etc. You'll know where that exactly is. But right here, we can go ahead instead. You could use the same thing and use pi over 4b to get the halfway point. So we have ourselves pi over 4, and then b is 1. So that gets us pi over 4. And then remember, it's comma a, which happens to be 1. Right, and that's our halfway point. So if we do take pi and multiply it by 1/4, that still gets us pi over 4 as well. So it works out nicely. Gotta love mathematics. So we have right here pi over 4. This will actually be pi over 2. And then over here, if we were to, that'll get us 3 pi over 4. So like I said earlier, the cotangent happens to be the inverse, so we're going to flip what actually happens. And it's going to go from top, we go down, and it goes top down from left to right. And there is our cotangent function. Okay, so if there happens to be any other vertical stretch, shrink, horizontal stretch and shrink, you pretty much use the equations that we've used right here on cotangent, and you should be able to get the same result. You should have 3 main points, the middle and the 2 halfway marks, and the asymptotes should help lead you to where the other, if we were to actually have 5 points, but remember, the function doesn't cross the asymptote. So the fourth and fifth point will be where the asymptotes are. All right. Good luck with this lesson. Make sure you come to office hours if you're having trouble.